Welcome to our graduation project presentation titled Deepfake Generation Using Generative AI. Throughout our project, we have engaged in extensive research on the latest advancements in face swapping methods. Our team has analyzed recent scholarly articles to understand and challenge the claims made by their authors. Today, we will demonstrate the results of these studies using our test images, showcasing the capabilities and the fidelity of the generated deepfakes. We will also discuss the technical methodologies, ethical considerations, and potential applications of this technology. In E4S framework, we begin by using a source image and a target image. A reenactment network is employed to adjust the source image to match the pose and expression of the target image, resulting in a new driven image. We also estimate the segmentation masks for both the target and the driven images. Next, these image and mask pairs are processed through a mask-guided encoder, which extracts style codes for each region to capture their distinct textures. Following this, we swap the masks and their corresponding texture codes. These swapped components are then input into a pre-trained StyleGAN generator that includes a mask-guided injection module. This setup allows us to synthesize the final face with swapped features. Our framework is designed to seamlessly integrate pose, expression, and texture transfer between the source and target images, utilizing advanced segmentation and generative techniques to produce high-quality results. Let me give you an overview of the regional GAN inversion method. The input face, labeled as I and its segmentation map M, are processed through a multi-scale encoder denoted as FI. This encoder extracts texture vectors for each region. These multi-scale texture vectors are then combined and passed through multiple MLPs to generate the style codes, which reside in a new R+ latent space of StyleGAN. Using these regional style codes and the mask M, our mask-guided StyleGAN generator produces the reconstructed face. Here are some pros and cons of fine-grained face swapping method. In these images, model can swap faces nicely, but there is a visible cut in the neckline which makes images unrealistic. The model performs poorly in rotated images. The model doesn't perform well in age differences and different skin colors. As you can see, model doesn't perform well in emotion changes.
The 3D swap method introduced in the paper utilizes a learning-based inversion algorithm to project 2D images into a 3D latent space, effectively capturing complex facial geometries and textures. It enhances this projection's consistency through a pseudo-multiview training strategy, generating images from various angles to improve modeling accuracy from single-view inputs. The core of the method involves a latent code manipulation algorithm that separates identity from other facial attributes using style mixing and interpolation for effective identity swapping. Additionally, joint pivot tuning is employed to fine-tune the parameters of the 3D generator, enhancing the quality and consistency of the swapped images, which can be synthesized to match the viewing angle of the source image. In the pseudo-multiview training step of the 3D swap method, the process starts by encoding a single-view image into a 3D latent space using a deep learning encoder. This step transforms the 2D input into a 3D model representation. Next, the system generates additional views of the face by adjusting the camera angles in the virtual space, creating multiple views from the initial single input. These synthesized views are then used to train the network, simulating a multi-view training environment. This training improves the encoder's ability to maintain geometric and textural consistency across different views. Here are some pros and cons of 3D-aware face swapping method. The model performs good in basic swaps. It performs relatively good in 45-degree swap, but not in 90-degree swap. The model doesn't perform well in skin color difference. The model performs really bad in facial accessories. As we can see, it also performs bad in different emotion swaps. Thank you for listening our presentation.